Alright, so in this video, in 7.5, and there's two formulas that you really need to pay attention to, and that's this. So if you're going to have the Laplace transform, oops, need a new page. So we're going to take the Laplace transform of u t minus a. That is, it's a transformation. You're sliding it sideways. You want the transformation of this whole thing. It's equal to e to the minus as f of s. Okay? And to do the inverse of that, it's equal to, of course, exactly what you thought it would be, what's on the inside over here. T minus a, and then of course f of t minus a. Okay? Now what does that do for us? Well, it just says this. If I want my t to start at 3, for instance, okay, and I have the function t squared, for instance, okay, so you look up the Laplace, well, it's not, I don't know t squared off the top of my head. Sure, yeah, I don't care. Let's do cosine, for instance. Cosine of t. Suppose I want to be cosine of t, which we know is s over s squared plus 1. Okay? Then if I want it to start at 3, I want it to be nothing prior to 3. So, excuse me, I would write it something to the effect of say, well, my point is I would write it like this. I would write e to the minus 3s s squared plus 1. Okay? What would that do for me? It would be, I want the cosine of t when t is bigger than or equal to 3. I want it to be when t is less than 3, I would like it to be 0. Okay? And so that's the game. That's how we're doing it. We start over there at that point. We just shift it over. Wow. So this would be our f of t. So our f of t is this thing right here, and then all we're doing is converting it over to a Laplace that makes sense for us. Okay, and so that's what the function says to do. And so, for instance, problem number, let's see, let's do number 2. It says e to the, so if you're starting off with, let's start off with a nice easy function. Let's don't do number 2 first. Let's do, oh, heck yeah, let's do number 15, for instance. So f of t is equal to sine t, provided that t is between 0 and 3 pi, and we want it to be 0 if t is greater than 3 pi, and the equal to is on this end. Okay? So in other words, the best way to write that would be to say f of t is equal to 0 when, oops, we should write this way first. Sine of t comes first. And 0 when we are greater than that. Okay? So that's our little function. That's how it is. That's kind of how it's set up to start with. Now we need to make the Laplace transform with that. Oh, just a second, I gotta answer the phone. Alright, so I'm back. So what we've done here is this. Before, we just had u of t minus 3 pi if we were scooting it straight to the right. But here we're always starting, we were starting at, say in the last problem we started at 3 and we went to infinity like this. Okay, but if I want to go here and I want to go this direction, then I'm going to do 1 minus this transformation. That will take me back over to here to 0. Okay? So if I'm going to go less than, a certain value, I'm going to go 1 minus this transformation. Okay? If I was doing it the other way around, then I would go just u minus t of 3 like that. Now, what does that mean? Well, it means if you distribute this out, you get sine t minus u of t minus 3 pi sine t. Okay? Let's do this one first. Sine is 1 over s squared plus 1. And of course, this is e to the 3 pi. Here, e to the 3 pi s, I should say. And here we just have, of course, 1 over s squared plus 1. Oop. So back to that. So there we have it. And we look at that and we say, okay, well, that's cool. And then, of course, your book, being the fancy pantses that they always are, will write that as usually 1 minus e to the minus 3, or e to the 3 pi s over s squared plus 1. Another one from that section, number, let's say 20. It says if you have f of t is equal to t if t is less than or equal to 1, it is equal to 1 if t is bigger than 1. Okay, so here what we have here, this just seems pretty straightforward. This top one is going to be 1 minus u of t minus 1 times t. Okay, and then, so that's for this top end guy. That's all pretty good. Now what about this bottom end guy? Let's just look at him as an individual piece. So that's just going to be u of t minus 1 times 1. So let's see what happens here. When I look at this piece over here, I think, all right, t, that's 1 over s, or 1 over s squared. It's 1 over s squared, I believe. Again, that's back on page. I can never keep track of them unless I have them in front of me. Back on page number, oh, for goodness sakes. Yeah, there it is. On page 1 over s squared. It's on page 446. So this is 1 over s squared. So but if I distribute through first, I get this thing here. Okay. And so if you convert this, okay, that's 1 over s squared minus e to the minus, or e to the s rather. E to the s times 1 over s squared. Now this one over here, of course, that's 1 over s, so that's e to the s times 1 over s. So now I have these two pieces here, right? So how does that all come into play? How does that work? What happens here when we look at it? Okay? So just a second here. Okay, whoops. Forgot these are negative s's here. Alright, so now here's the deal. All we have to do is combine these two guys together, because the Laplace transform says it's just this plus this. And so if you look at it, it's 1 over s squared plus, and I can take an e to the minus s out of both of these guys, and I will be left with 1 over s minus 1 over s squared. Okay? This will be my Laplace transform for that particular function. So that takes care of converting step functions. What if I have already the Laplace transform and I want to get back to where I came from? Okay, suppose you had f of s was e to the minus s minus e to the minus 3s over s squared. Okay. Well, first things first, let's break it into two pieces. It's e to the minus s over s squared. And it's, minus e to the minus 3s over s squared. Where'd this thing come from? Well, if you look at that, that is back on, that's the, back on page, that is our theorem that's on page, whatever page we were on. That's theorem 1 there, and it says you're just working backwards from it, right? So you have e to the minus as gives you t minus a. So, okay, well, that's a 1 right there. So you're going to have t minus 1 times, or u of t minus 1, rather. Okay, times, well, now what is this function here? 1 over s squared is just t. Okay, and you're going to have, what's going on right here with this goofy thing is what? Well, that's going to be u of, again, t minus 3, and then times t, like that. Now, where does this come from? How do we get to this point right here? Okay, well, they have a t in common, of course, and so how could we then work that back to some f of t? Okay, because this situation here is screaming like, hey, you know, I feel like this thing here should be, you know, over to the, you know, going to the right from 1. But if it's going to the right from 1, what the fink is this guy doing? Okay, so it feels like there's a little something weird going on here. We need to kind of figure that out. Okay, so we look at this thing here, we think, okay, well, so I see part of it. I feel pretty good about part of it, right? So if it was just this piece, you'd go, all right, well, f of t is equal to 0 when t is less than 1. Okay, great. What if it's between 1 and 3? I think we feel fairly comfortable saying that it would be equal to just this t minus 1 business. That is, this function here is what's going on. Okay? Okay? But then, little small correction, I wasn't paying attention to myself. Remember, this function is u of t minus 1. That's its transformation times the function, which is also t minus 1. Okay, so it's t minus 1. That's the function, all right, when we are between 1 and 3. So notice that if we're less than 3, this function doesn't pay attention to us at all. We don't care about this function at all. Done. Okay, what if it's 3 or bigger? Well, if it's 3, right, 3 minus 1 is 2, right? So it's just a function 2. Okay. This piece, of course, is gone because this is negative, and that's going to be a problem. Whenever that's a negative, we have a problem here. So this function peters out after we get to 3. Okay. And so we end up just with 2. Okay. And we start from t and we go that direction. T and we go this direction. All right, let's try another one here. See, this one looks fun. Okay, so what I see is I see cosine of some sort, right? See cosine of some sort, right? Cosine of pi. That's what I see. Okay, that's what I see of that part. This means it's been shifted to the right 1 unit, so it better be in here. And then, of course, that's u of t minus a, like so. Nope, t minus a, which, of course, is 1. Okay, so if we look at this, think to ourselves, okay, well, that's cool. So this is u of t minus 1. Okay, so we shifted to the right 1 unit. That's nice. And then we say, all right, well, if you blow this thing up a little bit, it would be nice if we could get rid of some of this, and we can. Okay, so the period here is 2 pi. Well, let's don't do it that way. Let's do it this. Let's leave it like this for a minute. Let's leave it like this up here for a minute. What's the period here? It's 2 pi over b, so 2 pi over this. Okay, so it's the period is. Oops, I'm sorry. It's 2 pi over pi. It's 2 pi over pi, which 2 pi over pi, which is 2. There you go. So this shifts it then half a period. Okay, which means that it's the idea of, you know, instead of being, you know, it's like adding 180 to it. So the cosine is going to be in the other side of the circle, and so this is very similar to saying, something like this: the cosine of x. How does that relate to the cosine of x plus pi? All right, well, that takes us on the other side of the circle. If x is over here, then x plus pi is over here. Their cosines are negative of each other. And so I was, when I was looking at this in the book today, I was like, or whenever I looked at this in the book the other day, I was like, what is this about? So what they did is they rewrote it like that, which is obnoxious, but it's the same as this. And I'd be perfectly happy with either one, to be quite honest with you. And so we would say f of t is equal to 0 when t is less than 1. And 1. And it is negative ut minus 1 cosine of pi t when it is greater than or equal to 1. Okay? And so that's what we're doing in that section there. It's pretty easy to do. It's just a matter of looking at the transforms of the graphs. That's all we're doing. Okay? And so not horrible. It's not terrible of a function at all. It's not really hard to do. It's just a matter of knocking it out a little bit for us. And I keep forgetting to show you this part of it here. This is just a translation of the one part. So when I look at this is just a translation. Okay? And so in reality, it comes out to be just this thing right here. Okay. I think I want to do one more of those just for fun. And we'll call it a night on those. Suppose you have okay, so I see a translation of pi, so that's u of t minus pi, okay, times the sine of t. Okay, that's what we're talking about here. So what we're saying is, okay, excuse me, we're just going to go pi units around the circle. So this, remember this, if you look at this function here, what you're really saying is the sine of t minus pi. And what is the sine of t minus pi? They should be on opposite sides, so that should be minus sine t, if all goes well. So when I look at this problem, it should be f of t is equal to 0 when t is less than pi, and it is negative sine t when t is greater than pi. Okay, and that's that. Okay. So theorem 2 then, it's a little different. Theorem 2 talks about for sinusoidal functions, periodic functions, and it says this, let f of t, it's periodic, period is equal to p, continuous, piecewise continuous, for t bigger than or equal to 0, then the transform f of s is equal to the Laplace transform f of t exists for every s bigger than 0, and it's given by, how fun is this, 1 over 1 minus e to the minus ps integral from 0 to p e to the minus st f of t dt. Yay! So it's about this juncture I'm feeling the need to break out my calculator. Going to open that up real quick. So let's try one of the dogs, shall we? So that's what the recipe is, and let's find the Laplace transform for Alright, so suppose we have this guy here. Okay, it's pretty easy to do. It's a square wave, if you will. What we're not showing obviously is the dot 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 where it drops straight down. And so it's piecewise continuous, so on its domain it is continuous. 1 all the way across here. Period is A, obviously. So when we do that, there it is. No big deal there. So the period is A. And so the recipe says you should do f of s 1 over 1 minus e to the as, like so. And now we're going to take the integral from 0 to p, which in this case is a, of e to the minus st times our function, which is 1 dt. Okay. Well, what is the integral of this thing? Well, it's minus e to the minus st from 0 to a. All this out front is just stays a constant, so 1 over minus e to the minus as. So if you plug that in at the top end, you're going to get a negative e to the minus at. At the bottom end, you're going to get a minus 1. Right? And so you're going to get 1 minus this. Okay? And so if we hold our mouth right, we get e to the minus at like so times this thing, or oops, minus e to the minus as rather. Should be an s. We do it with respect to t. And let's go back and try that again. Jay doesn't pay attention, he's doing very good. Now let's try it again. So let's try it again. So the integral would be negative 1 over s. There you go. So at the top end we're going to have minus 1 over s e to the minus as minus a minus 1 over s, I believe. Okay? And so you should get something like this then. If we plug it all back together, we see that we could rewrite this as, these guys have a 1 over s in common. Yeah, hold that thought. Sorry, my friend called. I had to take that. So I start over on this guy. Think about it a little bit here. The period is actually 2 pi, or 2a rather, because it doesn't repeat itself until you get to 2. Okay. However, we want to be 1 between 0 and a. We want to be nothing between a and 2a. Okay, so as a result, we're going to integrate from 0 to a. Okay. And so when you do that, you do it right this time. This bottom guy factors 1 plus e to the minus as and 1 minus e to the minus as. And then this guy cancels off. I canceled the wrong one. There it is. This guy cancels off. And you're left with 1 over s.